Dr. Daryl Ritchison, he is the director of the NDON system, and that's the North Dakota Agricultural Weather Network, which I use quite often and I'm a huge fan of. He works in Fargo, I believe out of NDSU, and his topic is expected weather patterns for the 2021 growing season. And so welcome, Daryl.
Well, it's good to be here. Like Frayne, I have a lot of information to cover in a reasonably short period of time. So we'll probably go through this a little bit quicker than some of you would like, but write down my email address. You're always welcome to email me. And if you want some additional information on me, I do have a blog at darylritchison.com that I put some information on occasionally as well as we go through time. So a couple of things there to think about. But anyway, very quickly, I just wanted to go over NDON, spend a couple of minutes. That past map was the cities that were on our current system. And for instance, this was the minimums today. If you haven't been looking up to your northwest, if you don't live up there, it is quite cold. Matter of fact, it's still in the teens below right now across much of the northern tier of North Dakota into northwestern Minnesota, and that cold air is sagging south. But like the rest of this winter, it's going to be pretty short-lived. We'll be warming up quite a bit by the end of the week. But the thing I wanted to mention here is we have 131 stations on our main map. NDON actually has 161 stations. And if you look very carefully on this map, just even around Fargo-Moorhead, we've added a station in Glendon, Wolverton. We have added a station out here in Air. We've added some stations up north of Devil's Lake, Wolford, near Clyde, Wales, some stations that we've added to. These stations are not currently available on our website. My programmer is working feverishly to get it all done. I do believe most of these stations will be available for the 2021 growing season, so fully integrated into our system, which means all of our crop models and guidance will be available. Those sites are transmitting data. It's on our cloud service. And this link down there, cloud.ndon.org, no www, just type in cloud.ndon.org. It doesn't work for all internet service providers, but a vast majority of internet service providers that would work for. And if you scroll down the page, the Minnesota list is longer than that. You just have to move your mouse down and get some of that data. But all the ones with stars on this page actually do not. Maybe I did put stars on this current page, but anyway, the sites that are not available on our main NDON page are available on this link. You can click on it. This is what the pages look like. Very quickly, there's a little calendar that you can click on for different time frames that you would want. You can scroll through these things with the mouse. I can't do it because this is a static image for you, but there's a lot of available tools on here. Plus, both on our website as well as our cloud service, we do have some soil data available. This is Wolverton. Notice our Wolverton has a camera on it, and those images are available in that cloud page. If you clicked on the pictures, we have about 50 sites with cameras on it if you're just curious what the weather is looking like in certain parts of the world. And this is an image of just northwest of Fargo this morning near Prosper. This is the Prosper NDSU research area up there. And I do want to mention that we do have two apps available. Our inversion app, which is mainly for spraying, but the current conditions are on there. So you can use it all throughout the entire year. And that inversion app is sponsored by these sponsors, which we are very appreciative of. And you'll notice one of the sponsors now is also the Department of Agriculture in Minnesota, which is where we picked up some of those sites in central Minnesota. Very quickly, if you go to our cloud service, we have soil moisture data now in almost 50 sites, one of which is in Wolverton, Minnesota. And very quickly, I just wanted to go over this, that soil moisture is done in this concept of volumetric water content. Of course, in the soil, there's solids, there's air, and there's water. And so what of that percent volume is actually water? Well, what happened right here in November? Notice this big drop. It just went off a cliff, soil moisture. What happened there? The ground froze. And so a lot of our pages will look like this, and soil moisture is not valid when temperatures are below freezing. What we have done, because volumetric water content can get confusing to a lot of people, is all of these sites on our cloud service only will have really the percent of saturation. So every soil type, of course, has a little bit different level of moisture that they can hold. And so if you go to our service, especially this upcoming spring, or this was Logan Center before it froze up, you know, our deep areas around 20 and 40 inches are not currently frozen. So you can see the deep soil moisture right now. But in the spring, this would be a good site for you to go to see what the soil moisture content actually is. So that was just a brief background on NDON. Want to go through 2020. I did not speak at this event last year, but this is Fargo's precipitation since 1881 to present, not including the final year of 2020 yet. But I show this because you'll notice that this is from the long-term average. Notice how long these bars are. You'll notice one thing very, very quickly. You know, we live here, we understand this, yet a lot of times people still get a little bit confused. Average means nothing in our climate. We are often one extreme or the other. And last year when I spoke about my 2020 forecast, I mentioned, notice these bars when they pop up, what happens the next year? Almost every single time you do the exact opposite. So I said, I bet 2020 rather, is drier than average just because of that reason alone. That's not even a forecast. That's just a statistical tool. And sure enough, last year in Fargo, we finished about 3 inches below the long-term average for the entire year. But of course, our principal concern oftentimes is just growing season. Well, before I get to the growing season, I've been emphasizing this in the last month in particular, and I wanted to take a couple of minutes to explain this graphic. Precipitation temperatures, when you watch TV, if you go on NOAA, all the time, you always hear this concept of, well, we're above average, we're below average. What in the world is average? Average is the 30 years in whole decades. A decade starts with a 1 and ends with a 0. What happened on January 1st, 2021? We started a new decade. So guess what? All our precipitation averages are now going to change. Our temperature averages are going to change. Really what we've done now is the old average was from 1981 until 2010. Our new average now is from 1991 through 2020. What happened? We exchanged the 1980s with the 20 teens. If you're old enough, much of the 1980s were dry. So guess what happened to our precipitation average? It went up. This is Fargo's 30-year average. So the first 30-year average was on January 1st, 1911. That was the first time we had full 30 years of records. Well, guess what happened? We went from very wet, because the 1880s, when some of your ancestors moved here, it was very wet. Our climate dried off, stabilized, and now we're in what I would describe as another wet phase, which is part of our ongoing climate. We have dry phases, we have wet phases through time. This has happened since the last ice age. So what has happened then this is just for Fargo, but this is very typical for pretty much every spot. You'll notice that first 30-year average we had in Fargo was about 24.5 inches of rain. It dropped off. It was in the mid 18-inch range in the 1960 average. Look at the 2020 average. Still not as wet as the first average. So everyone who always tells me this is the wettest we've ever been has no concept of what they're talking about. It's not true. But you'll notice our average is now up to 24. Notice the old average was about 23. So we climbed an inch. Most of the region, most of say Western Minnesota, North South Dakota, your average rainfall has increased anywhere from 1/2 inch to 2 inches. So what that means is this. I probably can tell you right now, 10 years in advance, that 7 or 8 of the next 10 years are going to be below average. That average, because that's going to be the average that we're going to stick with till January of 2031, 10 years from now. So it's always an important part to remember. Being 2 inches below average is not necessarily a drought. That's just the long-term mean. But Fargo, for an example, and I've done this with a few other sites, and it's been very similar. Fargo now, starting this year, has a full 140 years of records. Of those 140 years of rainfall records, 100 of them, by coincidence, have had less rainfall than our current average. Again, something to think about when we're dealing with precipitation averages in the future. All of these averages are based on the old average from 1981 to 2010 that I'm going to show you. This was end-on stations this past summer from May through September, the traditional growing season. You know, the southern Red River Valley, northwestern Minnesota, much of Minnesota, near or above average. But what was the dominant thing in 2020 was really drier than average. The only thing that really saved us last summer was that we had, or last growing season, I should say, is we had this period in July and early August where we had a lot of rain come down. July was very wet last year. This in western North Dakota was associated with one day. They got 3 to 5 inches of rain. Well, that's 50% of their average summer precipitation, or even more than that. Southern Valley had a couple of thunderstorm complexes. Minnesota had several. And northwestern Minnesota, the far northwest corner, had about 4 thunderstorm complexes. But even on this map, during the summer last year, more areas than not in the entire region were a little bit drier than average. This was temperatures last year from May through September. Notice most areas were a little bit above average, but last summer, and by summer, June, July, and August, wow, it was warm. And the great thing about last summer, it was warm without being hot. We had actually very few, most areas at or below average for 90-degree days. We were just very consistently 3-4 degrees above average every single day of the summer. So in turn, that was a lifesaver, because we all know what happened in most of North Dakota and northern Minnesota in particular on September 8th, 9th, or 10th. Not only did we have an early frost, we had an early freeze, which effectively ended our growing season 2 to 3 weeks, in some cases 4 weeks earlier than average, but we were able to get a lot of growing degree days in the summertime. So this is just the climate divisions from NOAA. I show these because this is the format I always show my long range forecast projections in. You know, again, no surprise here. Most areas were a couple of degrees above average, a degree or two, but here's the precipitation chart. Notice, even though there are some pockets of wet, you know, NOAA just classified them really as average. And I know, you know, some parts of northwestern Minnesota, I've shown this graphic too, and they go average, and generally followed by a bad word. And I understand that, but that's the thing, is that these projections are made in these climatic zones, not necessarily in a county, or more importantly, not on your particular farm or your acreage. But if you take a look at this graphic nationally, notice dry was much more dominant in 2020 than it was wet throughout most of the traditional, say, corn and soybean drought belts. So I'm just going to show you a quick graphic here. You can consider it entertainment if you want to, but I'm going to show you. This is the Great Lakes. You notice Lake Huron and Michigan are considered one lake. So this is actually Lake St. Clair, which is the lake by Detroit. I want to just put some stuff on this graphic and show you the past. That line was the late 1920s. The Great Lakes had reached a peak. What did we get after that? Correct, the dirty 30s. Strongest drought in the last 130 years. Here is another peak in the 1950s. What occurred in the mid to late 1950s? Drought, not so much. I mean, North Dakota and northern Minnesota was dry, but not the devastating droughts that, say, parts of Iowa, Nebraska, down through Oklahoma, the panhandle of Texas, you know, really south of where most of you are probably listening from, really tough droughts during that era. We reached another peak of the Great Lakes in the early 1980s. What happened in the mid to late 1980s into the early 1990s? Yep, drought, the worst drought in the last 30 years. And that's what we have just done in the last year or two. The Great Lakes have reached that same peak again. What do you think is coming next? I'll leave you to think about that. Here are some of the techniques that I use for 2021 going forward. I always remind people that the heat capacity of the planet Earth is not in the atmosphere, it's in the oceans. It's 99% plus is in the oceans. It's not the atmosphere. So really, to steal an old phrase from the Las Vegas Marketing Bureau, you know, what happens in the oceans clearly does not stay there. You know, it's 70% of the planet is oceans. So this is an animation from approximately Halloween until last week. And the thing that you will notice the most of probably many of you is this blue in the equatorial Pacific. Now, the key here is these are anomalies, not temperatures. So that area is below average. You'll notice in the North Pacific, for instance, there's a lot of red, and it's been fading as we go through the winter. And you think, well, Daryl, it's winter. Of course it's getting cooler. Again, these are anomalies, not temperatures. So this is where, where it should be. But, this area up here is red. It's bitterly cold. You fall into that water, literally hypothermia, you'll be dead in 20, 30 minutes. Think Titanic movie. It's bitterly cold, but it's still above average in temperatures. So really what's happening here in the Pacific Ocean in that area is a La Nina, which you probably have heard about. I always show you this actual temperatures just to remind people it's cold up there. And even though it's below average, it's still warm in the equatorial Pacific Ocean. It's just cooler than average. And of course, why this matters is where is most of the surface area of the planet is near the equator. We're round, so much of the surface area of the planet is near the equator. So 0 to 10 degrees north has way more land area than 80 to 90 degree north. And the Pacific Ocean being 38% of the planet, when the equatorial areas cool down, it's a huge, vast area. Almost always with a La Nina, when the water gets colder than average, global temperatures, the whole globe cools off a little bit. Might not in your backyard, but the whole globe average generally is. And that did happen this time as well. Very slight, but it's noticeable. And El Niños, which are a little bit more common or well-known, this is when the equatorial Pacific is warmer than average. What I didn't put on the definition is averaged over a 3-month period. So just a week or two wouldn't be considered one or the other. It's over a 3-month period. So if you take the model projections where we're at now, and we've really, this La Nina has very likely peaked, and we're going to be warming up from this point forward. Look on the bottom. These are the 3-month averages. That's June, July, and August, July, August, September. And notice where the overall mean is that we will gradually fade from a La Nina into probably neutral, but cold neutral conditions this upcoming summer. Now, one of the most common things in agriculture, really because of 1988, in many ways is when this started, was La Ninas equal drought. I'm here to tell you and remind you, no one thing creates weather patterns. It's not X equals Y, never. It's always say TUVWX equals Y. Now, La Nina or an El Nino might be the biggest factor of all of those conditions, but it's not the only one. So often the media, sadly, even some scientists will just go, well, this is happening, so this is going to happen. It's not that simple. It's a very complex thing. I don't have time to go over everything towards you, but this whole concept that La Nina equals drought, I can give you many, many examples where that wasn't the case, but I can also give you examples where it was the case. But in every instance, there was other factors going forward. But the key here is we are under La Nina right now. Matter of fact, if you look on the far right of the screen, this was by far the strongest La Nina or cold pool in the Pacific Ocean in the last decade. You'd have to go back to 10, 11, 11, 12 during that time frame to find a La Nina this strong. So one of the techniques that I use in doing my long range projections for the years and years that I've done this is this is where we've been the last few years. When have we been similar in the past? What was the weather conditions? What was going on? And then some of those other things besides just X equals Y, because this is, again, La Ninas, El Ninos, it's just one factor. How were the other factors in that equation? How were they interacting? What was similar? Because, Tom Sawyer, Samuel Clemens, has a lot of famous quotes. One of them was, history does not rhyme. I'm sorry, I'll redo that. One of his quotes was, history does not repeat itself, but it does rhyme. Well, I steal that. I used to have it on my office wall. I don't anymore. Weather does not repeat, but it oftentimes rhymes. By rhyming, again, it's similar, but they're always a little bit different. You can go through every wet year, every dry year, every average year. Everyone is unique. And 2021 is going to be unique in many ways as well. But I still go back in time, how many years were below average, above average? What was it stormy? Wasn't, back and forth. And so you try to do this examination. And really, I think it took people a while to figure this out. But since really the holidays ended, the last 3 weeks, the most common question asked me is, wow, Daryl, this winter has been very similar to the winter of 11-12. And you know what happened in 12. And I go, yeah, the last widespread drought in the United States happened in 12. Prices just skyrocketed. Corn prices skyrocketed. It was really a horrible cropping year for many areas. So is that going to happen again this year? Well, these are the same data. This is just last week's data. You notice this is 2012, where the oceans were back in 2012, right here, in comparison to this year. And again, there's more factors going on than this. But the thing I always try to teach people is what happens in the Atlantic Ocean does matter. And in many ways, I can find more correlations with precipitation in the Midwest with what's happening in the Atlantic Ocean over the Pacific Ocean, even though our weather comes from west to east in the mid latitudes. But you notice there's this cold pool along the west coast. This is a concept that deals with the Pacific Decadal Oscillation. That's not the case this current year, for instance. So believe it or not, 11-12 is not in my analog package. And I say analog because what are the years in the past that were similar? And usually what I do is I try to find 3 or 4 years that were similar, blend them together. And this was the overall average of those years. And it usually at least gives me an indication of, the odds favor us being below average, above average for precipitation, temperatures, for instance, going through that process. So again, 11-12 is not even in an analog set. What I'm saying is, could we have a widespread drought in 2012 that impacts everybody? Most certainly. It's the future. No one knows it. As I'm fond of saying, I'm just crazy enough to forecast it for a living. But on this is a bunch of alphabet soup. But you notice all these alphabet soups, except for one, end with an O. And these, again, are oscillation patterns, not only in the oceans, these are oscillation patterns in the atmosphere. Also, some of these are atmospheric oscillations, some of them are oceanic oscillations, but they're oscillations through time. And so there's more to it again than just taking one simple approach. But the La Nina, I do believe, going forward is probably the biggest factor. I just like to repeat myself again, it's not the only factor when you go through this. So if you've ever heard me give a long range talk before, I usually show this image. It's probably the only time in my life I will ever get to sit in a DeLorean, which was cool, but this goes to the movie Back to the Future, if you don't understand the joke, where I can go into the future, grab the weather data, and then go forward. I had an article published in a magazine, I think it's been about a year now, where in the article, and I was writing about long-term temperature trends and stuff, I said, if you could go into the future, would you grab the sports almanac that they did in the movie? I would grab a weather almanac. Because then if you had to knew what the weather going forward in time was exactly, I think in many ways you can make almost more money than what you can knowing what the sports scores are going to be. So what I'm going to show you then is my 2021 summer temperature analogs, and think, from Memorial Day through Labor Day, the core of summer, most of the growing season, using past data, years that were similar, and this is my temperature analogs. And the thing is, because I'm blending multiple years, you rarely get much in the scale one way or the other because you're blending. But you notice, this would indicate near or a little bit above average. Remember, 2020, again, we had an early freeze. We planted late because the first part of May last year, you may recall, even by our standards, it's horribly cold in early May last year. Some areas got, say, their corn planted in late April. And then, of course, it didn't emerge until the soil temperatures warmed up and they had a pretty good crop. But the key here is, I just don't think, historically looking back, we've never had 2 summers as warm as 2020 back to back. Therefore, why would 2020 and 2021 be any different? So this doesn't mean it's going to be cooler than average. I just don't think it's going to be as warm as 2020. But the thing is, the odds are we will not have that early freeze because we've never really had 2 years in a row with freezes around Labor Day either historically. So in turn, we might get just as many growing degree days in 2021 because our growing season will be longer. But I think the core of summer is going to be cooler next year for multiple reasons. And then precipitation analogs going forward. And again, this is my precipitation analogs. You notice most of the upper Midwest drier than average, but south of us, not necessarily. I personally think 2021 is going to be regional areas of dryness, not nationwide dryness like 2012. And if you think about it really carefully, if you've been paying attention to the weather, it happened again. Des Moines got yet another big snowstorm yesterday. It just finished. They got another foot. They've been multiple big snows and rains in this area. What have we gotten this winter? Nothing. And, you know, patterns do last sometimes several months in a row. This area has been wet so far. My analog package is suggesting that to continue into, of course, the upcoming summer. You know, do I call this a forecast? Not necessarily. It's trends, it's statistics. You know, I know no one should be changing their rotations based on these because they're 6-month forecasts, but that's the way it looks to me. But I always like to remind people, these two graphics are end-on. Of course, we didn't have as many stations back then, but this is 2012 and this is 2017, really the last two driest widespread years. And notice both situations, there are pockets where it did not finish below average rainfall because we get all of our moisture from thunderstorms. It's like when Frayne was showing the long-term rain projections in South America or the week. Do you think every single spot that he had green was going to be above average? It doesn't work that way. It's same thing here. People will ask me, hey, Daryl, I see the 6 to 10 day forecast is for above average precipitation. And I go, yeah, it looks like there'll be some thunderstorm complexes then, but it's not going to hit every single spot. There's always going to be dry and wet spots. There are exceptions. The fall of 2019, for instance, when it was different degrees of wetness, but everyone was wet. But most of the time, it tends not to be widespread. So really to sum up here quickly, to try to keep us all on time today, to me, there's reasons to think there'd be more dry areas than wet areas in 2021. I think March and April are going to be at least average, if not colder than average. I've heard this week that this goes against everyone else's forecast. So I've been getting a lot of people telling me, gee, Daryl, you're the only one I'm hearing that's saying this. And I tell them what I'll tell you. If March and April are warmer than average and we're planting early this year, because March, no matter how warm it is, we're not planting. But in April, we certainly can. I said, I'd be happy to be wrong. I don't forecast what I want. You forecast what you see, of course, going forward. But then once we get into May through the summer, I think, you know, then that time frame, you know, there's going to be cold periods. There always is. There's going to be warm periods. It's just the way that works. But overall, I think 2021 will likely be a bit cooler than 2020. Again, not necessarily below average, just not as warm and perfect in many ways that the summer of 2020 was going forward. And then the thing here that I would like to remind people is these decadal changes in the long-term precipitation mean. Not only that our averages are just changed, but as we go through times. I didn't have time in this talk because it was a shorter talk than some of the others I gave, but you have to remember this wet phase of our climate that we've been in lately has been going for about 25 years. Not all 25 years were above average, but most of them were. And the thing is, if you look back through proxy data for the last 4,000 or 5,000 years of proxy data, these wet phases within our climate tend to last anywhere from 15 to 30 years. And since 2006, that drought year, I've been saying, I don't think we're going to get out of this wet cycle until we get into the 2020s. And to me, there's hints going on globally that would suggest that. Doesn't mean 10 years of drought, but you have to remember our average now is skewed upwards. If we had, say, 5 years in a row with 3 inches below our current new average, drought would be thrown all over the place. I would look at it as, well, we just had 5 average years in a row. You know, you get used to certain things, but of course, Mother Nature doesn't keep things the same through long periods of time. So again, those are my contact information. If you would like to get in touch with me, please give me an email and you can ask some further questions, but I'll turn that off and open it up for a few questions here as we finish our program off this morning.
Well, thank you very much, Daryl, for the great presentation. I know it's one that producers really look forward to get your perspective on the weather outlook. So we do have a couple questions here that have come in. Obviously, when we look at the U.S. Drought Monitor and other mapping systems, it does show that, you know, a good portion of our area is under drought conditions. But we're also right in the middle of winter. So how do they determine the drought situations, you know, when we're covered in snow?
I get in a lot of trouble for saying this. I just really don't know how to answer that question without saying something that sometimes get me in trouble. Tom Sawyer, Samuel Clemens has a lot of famous quotes. One of his famous quotes is lies, damn lies, and statistics. I change that and say lies, damn lies, and the drought monitor. I've never seen a drought monitor in my 30-year career that I agree with. Sometimes I have no idea where they come up with it. They had an area in Stutsman County in severe drought a few weeks ago, and there were areas far, far drier than them the entire summer that were not even in completely different ranges. And, I had a lot of people ask me, where did they come up with that? And I go, voodoo? I don't know. It made no sense whatsoever. Endon has 50 stations with soil moisture now. The Red River Valley has abundant moisture under 1 inch in the soil. To me, if you're thinking the Red River Valley's in a drought, you don't know what the word drought means to me. West Central and Western North Dakota is dry, and they're probably in a slight drought. And if my forecast for 2021 comes true, then I'll give you it's a real drought. But to me, drought is way overly used in agriculture and many other areas too. And so I really can't answer that question. I'm not part of the drought monitor team. Sometimes I wished I was, sometimes I wished I wasn't. But outside of central and western North Dakota, most areas in Minnesota, northwestern Minnesota, eastern North Dakota are not really that dry. And I always remind people, we only average 2 inches of precipitation in the winter, which is 1 thunderstorm in the summertime. Droughts just don't end or can't start in the wintertime. That's just crazy to me. I understand that, the topsoil is dry, especially you get west of the Red River Valley in North Dakota. There's no doubt about that. But 1 rainstorm in April and the word will go away. To me, if 1 rain can change a drought, it's not a drought. You're just dry a little bit, but nothing's going to change much this winter. If we're going to get those areas that do have soil dry problems, especially again west of the valley in North Dakota, it's really going to be a matter of April or into May. And truth be told, how many of you want it to rain a lot in April so you can't go planting? No hands will go up. So really the key is, in many ways, it'd be nice if we, in a perfect world, stay dry or just get a little moisture, nothing too big. And then once everything's planted, get a couple of good thunderstorms and go forward. But I don't think personally that we're going to change the dry conditions realistically until May, because it's May usually that we get into what I call our rainy season here. Because even into April, we average very little moisture. Even April, we usually get more evaporation than we do precipitation for the overall average. So I know that doesn't really answer the question, but it's really the best I can do.
Thank you. That does give a very good perspective, though. Another question, keeping on the drought topic, how long do droughts typically last? And is there a certain season when droughts typically break? I guess you kind of said that doesn't usually happen over the winter, but is there a pattern at all?
I don't really think so. I always remind people of the old saying that all droughts end with a flood. Everyone's heard that correctly. I do believe, if I had an audience that I could see, people would say, shake their heads, yes. I also remind people that all droughts start with a flood. And in the fall of 2019, when it was really wet, I spoke out in Western North Dakota to a bunch of ranchers, and they were talking about wet, 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 wet. And I said, personally, I think you should talk about dry, 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 dry. You're going to be very thankful of this rain once we get into 2020 is my very strong suspicion, which ended up being very, very true, because it's odd that those old sayings aren't scientific, but they're some way true. There were some, say northwestern Minnesota was phenomenally dry last April and May. And if you were in that area, Kitson County, wow, they got 7, 8, 9 inches of rain in like a week, and they all flooded very, very quickly. So again, droughts and dry periods, only takes 1 precipitation event oftentimes to do it, but we get a vast majority of our precipitation in these parts from about May 15th through July 15th. And I always tell people, if you're still dry on June 15th, that's when you should start to worry about the summer. Last summer was not a good example of that, because a lot of areas, Fargo was one of the driest years on record until the end of June. And then we had a magnificently great July and did wonders for the crops in the southern Red River Valley. But most years that doesn't happen historically. So to me, to really answer that question, to get them started or end oftentimes comes with that 60-day period between mid-May and mid-July, because that's again when we average a huge percentage of our precipitation in these parts.
Okay, thank you. We just have a couple more questions if you still have some time.
Sure.
Okay, going back to the slide about El Nino and La Nina, are El Ninos becoming more extreme? It looked as if the very strong El Ninos are trending up.
Yes, but it's a statistical thing that we didn't have the same amount of data in the 1950s, 60s, 70s, and 80s that we do now. We didn't have satellites in space in the 1950s. So those El Ninos are based on ship data only for the most part. We had very few buoys in that area. So again, you have to sometimes equate when you think you see trends, why is that trend there? You just can't take it. Data does not equal data. There's a lot of crappy data out there. It's just a reality. We have a lot of politicians, a lot of people, even scientists, data, 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 data. But how good is the data? And I'm a very end-on, I don't want to put out crap. We work very, very hard to keep every one of our stations at research grade, perfect data, at least as close as you can get to perfection. You never get there, but you come close. So that trend line in many ways is associated with lack of data back in time. I personally don't think that they're really getting any worse. And the trend lines we're talking about are fractions of degrees, which again, our sensors don't do very well. So yeah, there's no doubt just looking at that, there looks to be a trend there. I will ask the question, is there really a trend there?
All right. Regarding end-on stations, someone wants to know if there are plans for stations in Burleigh County.
That's an excellent question because I just got a $6.4 million grant through the United States Army Corps of Engineers. And we're working on a project with them over the next 5 years to expand our knowledge of winter precipitation in the upper Missouri River Basin. The one climate element really all across the northern tier of the United States is winter precipitation. Because when it snows, yeah, you'll get 100 people tell you how much it snowed, and most of them measure it on their deck. So it's not very accurate, but it gets them on the news. And the reality is the snow is irrelevant. I mean, I have to shovel it like the next person. It's the moisture content that's important. We really do not have a good history of winter precipitation in, say, a large scale area. And so a lot of times the flooding in the spring is missed because, wow, we just did not know how much moisture is in that snow. That project I'm working on is only for the upper Missouri River Basin. So it's the James River flows into, of course, the Missouri. So the James River Basin, the Missouri, the Little Missouri, and North Dakota. I will put new stations in place. So Burleigh and Morton County, and then up in Oliver County, the really one big dead spot I have in my network will be infilled with this project going forward. And all of these stations that are out in that area, all the stations will get all season rain gauges. They will all get snow depth sensors. They will become, NDON will transition these stations from great stations to awesome stations. So if you're patient in Burleigh County in the next few years, we will get some NDON stations out there through this grant.
That's great to hear.